Hi everyone, today we'll study what is BFS. BFS is a type of traversal for a graph or a tree where we start with an option first, get all the options from that option and iterate each of those options one by one sequentially, and then add the further options from those options to a queue, so for future reading. And while we have traversed the first option and add the other options from the first option to a queue, we remove the first option from the queue so that it is not reread again and is not processed again, and you don't enter into a infinite while loop. So we do that for the reason that we do that by level, or we do not go to a depth from one option to another and from that option to another option, while leaving the other options which are in the same level and going inside the tree or a graph and then come back from the stack. So the data structure which is used in BFS is a queue, and for DFS it is a stack. So we'll study DFS later on, where we go into a depth and then come back exploring everything if we have not found another option. While BFS is you get an option, check it, remove it from a queue, find all the options from the option which is removed into the queue, get the first element from the queue, process it, check it if it is our answer. If not, or if it is, just add it, remove it from the queue and add all the possible options from that option to the queue for future use. So if you, I'll take an example from lead code. If you look at this example, from 3, there are two options, right? There are two neighbors of 3, which is 9 and 20. And while first uh, uh, responsibility is add 3 to the queue. Now when you have added 3 to the queue, just get 3 out of the queue and check all the options from 3, which are 9 and 20. You add it to a queue. So now when 3 is removed from the queue, what remains in the queue is 9 and 20. You get the first option, which is from the queue, which is 9. Check what are the other options from 9. There's nothing. Then you do not add anything. Then you just remove 9. Check, get 20, remove it, check what are the options from 20 going forward, which are 5 and 7. Then add 5 and 7 to the queue. And then when you remove 15, you see what are the options from 15. There's nothing. Then for 7, there's nothing. You just remove 15, 7, and you have nothing to process. That's where you end. So there's nothing else to process. This is a BFS where you process a node, process all its neighbors one by one, remove them from the queue, and while you remove them, you add the options from those neighbors to the queue, right? So we'll just write the pseudocode first. Add the start to the queue if it is valid, right? If it, what is validated in our case, it is not null, is not null, right? And then you do that when you have options. While you have options, you, what you do is you remove the elements from the current level and then add the options or elements from that individual option you are removing, right? So while you remove, you also process. So we'll just add a small code here. You, while you remove, you process them. That means in our case, we just save them, right? We are not checking for anything, or we are not processing. Just process it. For us, it will just add to to our answer. So what we do is first we have to declare a queue, right? So our queue will hold what type of uh, elements? It is a tree node type. And then what we do is we create our answer. Answer is actually a list of integers, right? List of integers where complete list is an answer, and each list in the outer list is a level, the elements in that level. So in this level there is 3, in this level there is 9 and 20, and then there is a third list of 5 and 17, 5 and 15 and 17, sorry. So we just declare our answer. It will hold, this is a list of a list. So we mentioned that we never add a null or a non-invalid option into our queue. So we check that if root is not equal to null, only then we add it to a queue, right? So what is the difference between offer and add? If you are running out of your RAM or memory allotted to the JVM, add will throw an exception while offer will detect it and will not error out. So always try to use offer in your production code. So what we do is we go until you have options. Where are options stored? Options are stored in our queue, right? Until our queue is empty, we keep processing it, right? That means we have work to do, right? So what we do is we every time we enter this while loop, we know how many elements exactly we have to remove, which define the current level which was last added, right? So we check how many elements are there in that level. So q dot size will always hold the number of elements in the level which was last added. So what we do is while len is greater than 0, we remove those elements one by one, right? So we get tree node, we do a removal from the queue, and here you have to note one thing, right? So we remove the element from the queue and then process it. In our process, in our question, what is the meaning of process? Process means we have to just traverse and add them to a list. So we, for every level, we'll just declare a list which hold the elements in that level. So those will be added one by one as they are removed to this list. So we add the node dot value, not the exact node, right? Because answer demands that here. So what we do is you have noticed that in the first attempt, we always add a valid value to a queue, right? So if node which was removed dot left is not equal to null, then only we'll add. If it is null, there is no point adding. Right? Similarly, if there is a right child, we add it to the queue. And then we do len minus minus, because we have to do until all the elements in the current level are removed, not the one which the further options we have added here, right? So at this point of time, what we do is we have this populated and then we'll add it to our answer. And this will go on until there is no other further option to explore. So this thing is processing each level, and it is processed until there's no option. Remember, we do not add a null value to the queue. So after everything is done, what we do is we just return our answer, which is actually a list of integers, which is a list of values in all the levels, right? So just run this. I'm sorry for the typo. I'm sorry for the typo again. Here is another problem. Hmm. Okay, so we'll submit it. Thanks. With that, I'll end the demo.